This list has come to my attention several times, so I decided to address it. Since creationism stems from scientific ignorance and lack of understanding, understanding these answers to the things on the list can be an excellent learning experience. So to begin, question number 1. Where did the space for the universe come from? Question 2. Where did matter come from? Question 3. Where did the laws of the universe come from, such as gravity? Question 4. How did matter get so perfectly organized? And question number 5. Where did all the energy come from to do all the organizing? Are completely irrelevant. Evolution is biology. These questions relate to theoretical physics. If you are ignorant enough to not be able to tell the difference between physics and biology, you really don't have any room to feel qualified to overrule every credible scientist on the planet who says that evolution happens. So, we can strike these questions from the beginning, just simply because they're completely irrelevant to evolution, and evolution deals with life only once it's already here. Question number 6 states, where, when, and why, and how did life come from dead matter? Well, this is covered by the theory of abiogenesis, which also is not evolution, because once again, evolution deals only with life once it's already here. In fact, I did a video on abiogenesis, which you guys can check out here. Question number 7. When, where, why, and how did life learn to reproduce itself? Well, that comes from the very nature of self-replicating systems in the sense of they tend to accumulate. For a fantastic example of this, check out C. prions and mad cow disease. But to answer the question specifically, reproduction existed before life did. Question number 8. With what did the first cell capable of sexual reproduction reproduce? Bacterial conjugation, well, the answer to this, rather, is that bacterial conjugation was likely the first form of sexual reproduction, and an unsuccessful division of a cell is simply enough to create a diploid organism just from the bat, which is an extremely simple task to do. It happens all the time, and oftentimes it's responsible for Down syndrome in the sense of non-disjunction. Understand the distinction that here we're talking about non-disjunction in multicellular versus single-cellular organisms, and many of the downfalls associated with what would happen in a complex organism such as humans simply aren't associated with single-celled organisms. In fact, it's so common that this is exactly what is responsible for Down syndrome. Also take a look at the simple fact that sex has many advantages. If you recall the quote from Darwin that it's not the species the strongest or the fastest or anything like that of the species that survives, or that's most likely to survive, it's the one that's most responsive to change. And being responsive to change is a direct result of having high genetic variability. So what sex enables organisms to do is increase the genetic variation that they can possess and increase the likelihood that they'll be able to survive. And indeed, the Cambrian explosion was due to sex. That's where all the different body plans came from. Number 9. Why would any plant or animal want to reproduce more of its kind, since this would only make more mouths to feed and decrease its chances of survival? Well, again, you always have to be careful of using verbs with evolution, because evolution isn't a conscious entity. It doesn't want to do something. It doesn't need to do anything. It's simply due to the nature of self-replicating systems in the sense of that they tend to accumulate. It's really no surprise there, and it's basic biology. Question number 10. How can mutations create any new improved varieties? Well, once again, mutations add variation, which the cheetah and greater prairie chicken examples, check out these videos, show is extremely important, because genetic variability is the key to an organism's adaptive success. Again, this is all basic biology. Check out this video that I did on mutations as well, because it'll prove pretty helpful in answering this question. Question number 11. Is it possible that similarities in design between different animals prove a common creator instead of a common ancestor? And the answer to that is no, absolutely not. And here's why. Because it has nothing to do with the similarities or the differences, it's solely with the pattern that emerges when one examines them that is only explainable by common descent. In fact, it's such a big fallacy that I actually did a video on it explaining this, and this pattern and common descent in phylogenetic trees are the reason that I can personally use 16S ribosomal typing to diagnose idiopathic oral infections when I know what the organism is and you can treat it. However, if you don't know what the organism is, you can't. And this technique relies solely on evolution and the pattern, which once again is only explainable by common descent. If a common creator was the cause of the pattern that we see in the genomes of the organisms that exist today, then it would be useless, but that's not the case. Question number 12. Natural selection only works with the genetic information available and tends only to keep a species stable. How do you explain the increasing complexity in the genetic code? Well, once again, that has absolutely nothing to do with natural selection. That's due to gene duplication and subsequent mutation. And this is very basic biology. Again, see this video on mutations that I linked you guys to earlier. Natural selection deals only with the information once it's already there. That's really no surprise, and it's just basic evolution. Question number 13. Where, why, when, and how did A. Single-celled plants become multicelled? Where are the 2 or 3 cell intermediates? To examine how something evolved, it's often best to take a look at the tree of life and see what current existing organisms possess, in the sense of, from that, you can see exactly how things and certain traits evolved and their order. But doing so, one really doesn't have to look much further than to see Volvox, which is a multicelled organism that's comprised basically of single cells. There are no true tissues or anything like that. After that, you can take a look at Porifera and things like that, which are essentially sponges, as they also provide an excellent example. Question B, how did single-celled animals evolve? Well, I'm not really sure exactly what the question is there. Single-celled animals or single-celled organisms to begin with, because again, that'd be abiogenesis. 13C, how did fish change to amphibians? Excellent example. Check out the Transitional Fossils playlist that I have in my channel. Here's a link to it. It goes on to exactly how that change could have occurred, and in fact, there was a new transitional fossil discovered about 2 weeks ago. The gaps are, it's ridiculous, the amount and the rate at which we're finding things. In fact, it's so predictable, and the fossil record is so good that we can go to a certain place, predict the depth at which to dig, and have a mind or have an idea of what the transitional fossil that we're looking for should look like, and discover it in that location at that depth. That is how reliable it is. And in fact, that's exactly what was used to develop or to find Tiktaalik by Neil Shubin and company. D, how did amphibians change to reptiles? Again, also in my Transitional Fossils playlist. Question E, how did reptiles change into birds? Once again, Archaeopteryx provides an excellent example for that. And before you all go and quote mine fiducia and things like that, check out my Creationism Dishonesty video, as many of the quote mines have to do with Archaeopteryx. But again, check out in terms of the transitional fossils and how this actually happened, check out my Transitional Fossils playlist. The link is right here. F, how did intermediate forms live? Once again, all we have to do to find this is to look at nature right now. You would think that an animal that would, like a fish and amphibian mixture, would be so awkward that it could never survive, yet take a look at mud skippers and lungfish. They provide perfect examples of intermediate forms living, one that's good at adapted in land and in water, and they've survived perfectly fine. Question 14, where and why did A, whales evolve? Fortunately, whales have actually left a really phenomenal transitional fossil series, as indicated by this playlist. Once again, it's a Transitional Fossils playlist that I have. In fact, whale evolution provides a fantastic example of the predictions that evolution makes and subsequent findings which support evolution. B and C, how did seahorses and bats evolve? That's relatively irrelevant. If you're really interested, do a Google search on it. It's pretty simple. 14D, how did eyes evolve? I actually have a video on how the eye evolved. Check it out. Here's the link. Question E, how did ears evolve? That's a fantastic question, and in fact, check out this video right here that I actually made. It's part 4, embryology, and basically the middle ear evolved, if you take a look at embryology, you can clearly see that the quadrate and the articular bone in reptiles forms into 2 bones of the middle ear in mammals. So in any transitional fossil, we have to see these bones of the jaw in reptiles transitioning into bones of the middle ear in mammals. And the transitional fossils that we find perfectly demonstrate this. So ear evolution is actually a wonderful, fantastic example of the predictions made by evolution and it fulfilling them. F, how did hair, skin, feathers, scales, etc. evolve? Well, hair and skin are essentially relatively the same thing. In the sense of hair is simply keratin that's excreted from the skin. In modified sweat glands, so that's nothing really new. Feathers are histologically similar to hair, so there's really nothing very different there. Scales, nails, etc. Again, claws, all variations of keratin, which is found in all of our skin, because most of our skin is keratinized epithelium. 15. Which evolved first? And how did they work without the others? Well, this is a fantastic example of what you can learn from examining claims like this. The answer to this question is, if it can grow, it can evolve. So, for example, if you were to take a look at the giraffe neck, where there are certain valves or whatnot, and creationists will often assert that for the giraffe neck to be so long without all these valves, the giraffe would die if they weren't there. So what evolved first? The valves to let the neck grow long, which would be purposeless without the long neck, or the long neck without the valves, in which case it would lead to death. Well, they evolved together, in the sense of for every inch that the giraffe's neck grew, these valves had to grow as well. So by examining how something develops and understanding that things can co-evolve, and it wasn't all one trait and then all another, you get a pretty good sense of how evolution works. The remainder of these things will be covered in the second part to this video.